Hi, my name is Kieran Bernard and I'm an applications engineer here at Slew Corporation. When considering which op-amp works best in your application, a couple of things that you usually think of is, number one, does this device give me the accuracy I need in AC or DC performance? Does it have enough bandwidth for my application? And how do those parameters that I care about shift over radiation? What we've done here with our new device is that we've combined the best of all three worlds for you so that you no longer have to choose. So, is this part accurate? Well, when it comes to DC, the VOS of this part at mid-supply is 300 microvolts. When you consider the entire common mode input voltage range, we're looking at 400 microvolts, and that number stays pretty stable across radiation as well. So in an AC scenario, you've got the slew rate response, which handles the large signal steps, or the small signal response, which you can see here, against the competitor T. You can see that our part has minimal overshoot during the transition, and it also settles a lot faster to the final value. For a slew rate response, the part is able to keep up with the output with minimal error. So here on the bench, we've actually got both the devices here. We've got our ISL70444 alongside competitor T. We've got the power supply here, which is feeding both the parts, and a signal generator and a scope here, which is monitoring both the input and the output. So here we've got the input signal to both these op-amps here at 300 kilohertz at a peak-to-peak voltage of 500 millivolts. And we've got the Slew part in blue and the competitor T in red. The yellow here is the input signal that we're feeding into both the op-amps. Here you can see that both op-amps are producing somewhat of a square wave, with the Slew part doing a better job. But let's crank up the frequency and see what happens. So I'm gonna crank it up to 500 kilohertz. Let's go a little bit faster. And now we're sitting at 1 megahertz. And you can actually see the competitor T starting to lose the definition of the square wave that we're feeding into the op-amp, whereas the Slew part here still is able to retain the square shape of the input. When it comes to total ionizing dose, the ISL70444 doesn't really move a whole lot across radiation. It is rated for 300 kilorads at a dose rate of 50 to 300 rads per second, and 100 krad at a dose rate of 10 millirads per second at initial characterization. Each wafer that we ship is assurance tested to 50 kilorads low dose rate. We've also done extensive SEE testing. We don't experience burnout all the way up to plus minus 21 volts on the supply, which is actually the ABS max for the process this part is built on. And thanks to Slew's SOI construction of the PR40 process, it is immune to single event latch-up. And if your application requires high DC accuracy along with superior AC performance, this part is for you.